Let's look at the radiated emissions of a mixing product on a clock harmonic at 887.5 MHz. We've zoomed in to a 100 kHz span and a tighter RBW to see the noise more clearly. We've also switched to a pinpoint probe here to really isolate where on the board these signals are coming from. And we've been able to locate it going into the MSB bit into one of the D to A's on this board. So we can now capture it on the oscilloscope. If we look at the oscilloscope, we can see that there's a sweeping square wave that completely matches that aberrant signal that is emitting every 30 seconds or so. And so with the scope, we can also go ahead and look at the history and turn that on. And we can see how that's really logarithmically sweeping that square wave up, and that's causing the emissions to increase dramatically. And then when that signal resets, if we look at the spectrum analyzer, we can see that reset as well. So we found the root cause. The MSB bit on this D to A is causing these emissions. So now we can really decide whether we want to change our code, whether we want to do something else about it, or whether it's going to be fine. So that's the final step in how you use instruments together like this real-time spectrum analyzer and the scope to finally debug your EMC emissions problems.